Hello everybody! Today we're going to talk about multiplying rational numbers. As you know, rational numbers can mean decimals or fractions, but in this case we're only going to focus on fractions. Okay, so here are the steps to multiplying rational numbers. The first thing that you need to do is make sure that all of your numbers are in fraction form. That means if you have any mixed numbers, make sure you change them to improper fractions. And also, if you have any whole numbers, like the number 5, make sure that you write that in fraction form. So you would want to write that as 5 over 1. Once you have all of your numbers in fraction form, what you're going to do is you're going to look to reduce your problem either up and down or diagonally. We'll talk more about this later. Then you simply multiply your numerators together, multiply your denominators together, and then simplify your answers. All right, so let's go ahead and talk a little bit about this simplifying thing that I'm talking about. Why don't you go ahead and pause the video and write down these two problems, and then we'll walk through them together so you know how to reduce up and down and diagonally. Okay, so hopefully you have your problems written down. So what we're going to do in number 1 is the first thing, we want to look at each fraction individually. See how we have 2/3 here and we have 3/4 over here. We just want to check and see if either of those two fractions can be reduced. In this case, 2/3 cannot be reduced and 3/4 cannot be reduced. Now, what's special about multiplying fractions is not only can you reduce these fractions up and down like this, but we can also check diagonally to see if fractions going this way can be reduced. So, for example, if you look on this diagonal, we have 2/4. And so, in this case, we can divide 2/4 by something in order to get it reduced. We can divide them both by 2. So if I take 2 and divide by 2, I get 1. And if I take 4 and divide by 2, I get 2. That's what reducing diagonally looks like. Now we can go and look at the other diagonal. And if you notice, we have a 3 and a 3. And so we can divide both of those by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. And now everything is reduced, so we're going to go ahead and multiply the numerators. 1 times 1 is 1, and then multiply the new denominators. 1 times 2 is 2. So our fraction is equal to 1/2. All right, let's take a look at number 2. Now, sometimes I notice that kids are confused about that negative sign in the front. So let me just point out to you that if I write negative 5/12 with the negative sign in the numerator, that is the same exact thing as saying negative 5/12 with the negative in the denominator. It's also the same thing if the negative sign is in the middle. So if it's easier for you, sometimes it's easier for me, instead of having it be in the middle, I like to write it in the numerator position, so I think of it like negative 5. All right, so now let's check up and down and diagonally to see if we have anything to reduce. So let's look at this first fraction here, 5/12. Can we divide 5 and 12 by something to reduce that fraction? No. 3/8. No, not that either. So now what we're going to do is we're going to look diagonally. We have a 5 and an 8. Nothing goes into 5 or 8 evenly. 3 and 12. Aha, there we go. So what we want to do with the 3 and the 12 is we want to divide them both by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Now what's important here is that you may notice that if you look across at the denominators, you have a 4 and an 8. Please do not reduce anything going left to right. The only way that you can reduce is if it's up or down or diagonal, okay? But not across. No, no, no. See, it kind of makes like a no, like you're shaking your head no right here. Can't go across. Up and down, yes, you could do up and down. Diagonal, yep, you could also do diagonal, but across, no way. Okay, so now that we've reduced the 3 and the 12, There isn't anything else that we can reduce here, so we're going to go ahead and just multiply our numerators. Negative 5 times 1, which is negative 5. And then our denominators, 4 times 8 is 32. So our answer is negative 5 30-seconds. Okay, lucky you. Now it's your turn to go ahead and try a couple. Pause the video, write down numbers 3 and 4. Make sure you show your work. Reduce your fractions as much as you can. Go ahead and multiply and then simplify. And then play the video to check your work. Okay, let's see how you did. So first we're going to go ahead and look at our reducing. If we look up and down on both of these, I see that I have a 9/12, so I can divide the 9 and the 12 both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. Now that I've checked up and down both fractions, I'm going to look diagonal. I have a 3 and a 4, can't do anything about that. And then I have a 3 and a 4, can't do anything about that either. So I'm going to go ahead and multiply. Negative 3 times 3, that's negative 9. And then 4 times 4 is 16. Now here's the deal. Sometimes you don't always notice that you can reduce. But that's okay because you're still going to get the same answer. So if I didn't reduce the 9/12 and I just ended up multiplying, I would have gotten negative 27 over 48. Well, once I divide both of those by 3, I still end up with negative 9 over 16. Some of you may have noticed also that you could have reduced the 3 and the 12 going in this direction. That's okay too, and you still should have gotten the same answer. All right, let's check out number 4. So number 4, the 6 is not written as a fraction yet, so we're going to put that over 1. And then we're going to look to reduce. Up and down, nothing. Diagonal, nothing there either. So now we're going to go ahead and just multiply. You may hear my dog walking around. He seems to want to be pretty active as I'm making my video. So we're going to take 6 times negative 3. That's going to be negative 18. And then on the bottom we have 1 times 11, which is 11. Okay, so now the only problem here is this is not simplified. This is an improper fraction, so we need to change it to a mixed number. I noticed that the fraction is negative, so that means we're going to have a negative mixed number. And now, just in case you don't remember how to change an improper fraction to a mixed number, what we're doing is we're doing division. See the fraction bar right here? That means divide. So we want to divide 18 by 11. 11 goes into 18 once with a remainder of 7. So now this right here is going to tell us what it is as a mixed number. Again, we know it's negative. How many times did 11 go into 18? Once. And what was the remainder? 7. The denominator always stays the same, so you just bring that over. And there we have it, negative 1 and 7/11. Sorry, it kind of looks like a smiley face, so I gotta just go ahead and do that. Okay, moving on. So now let's do some mixed numbers. We're gonna do the first one together, and then the second one you're gonna do on your own. So remember that the very first step to multiplying fractions is to rewrite the mixed numbers as improper fractions. So pause the video, go ahead and write down number 5, and then play the video when you're ready. Okay, so let's see here. First thing you should have done is changed your mixed number to an improper fraction. So this first fraction, 12/5, is going to stay the same. But the second mixed number is going to change to 2 times 2 plus 1, that's 5. Denominator stays the same. Now we have a multiplications problem, just like on the previous slides, where we're going to look to see if we can reduce it all. So if I look up and down, I can't divide either of those by a number. Over here, nothing. Here we go. I have a 5 and a 5. That means I can divide them both by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And now looking in the other direction, I have a 2 and a 12, so I can divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. All right, so now we just multiply our numerators. 6 times 1 is 6, and 1 times 1 is 1. So simplified, we get the answer of 6. Okay, go ahead and pause the video, try number 6. Just a quick note about it though, when you go to change this mixed number right here to an improper fraction, you actually just ignore the negative sign, do 6 times 1 plus 5, and then just make sure to bring that negative sign down into the problem. So go ahead and pause the video, try it on your own, and then play the video to check your answer. Okay, I'm wondering how you did on this one because I notice here that I have a 6 and a 33. That one is a little tricky, but you can divide them both by 3. 6 divided by 3 is 2, and then 33 divided by 3 is 11. Now, if I multiply, I get negative 121 over 32. And then to simplify this, you may have to do some scratch work on the side, but luckily this is a video I'm making, so it's your lucky day. We know that the answer is going to be negative. 32 goes into 121 7 times. That gets us to 112, so that means there's 9 left over out of 32. So our final answer is negative 7 and 9/32. Nice job. Okay, last thing that we have to talk about today is how to multiply algebraic fractions. So here we have fractions that have variables and numbers. So what we're going to do is we're going to kind of do this the same way we were doing regular fractions. If you notice, all 3 of these problems have exponents. So what I would recommend that you do first is take out the exponents and expand. So what I mean is on this first one, we're going to write it as 2a over b times bb over d. Okay, so now we're still going to look to reduce. So if we look up and down, I don't see any 2 numbers that I can reduce here, and this one doesn't have any numbers at all. Diagonally, no numbers in common. Diagonally this way, again, no numbers in common. So the next thing we want to do is we want to take a look at our variables. If you remember correctly, when you have a number over itself, that is equal to 1 whole. The same thing happens when you have variables. So if we have b over b, that is equal to 1. So when we go to look to reduce, we're looking for 2 b's that would match up, just like this right here. So looking diagonally, I notice here's a b and here's a b. So that's like saying b divided by b, which equals 1. So this is equal to 1 and this is equal to 1. If you want to think of it like they cancel each other out, that's fine. So you can pretend like they're no longer in the problem. Then we look in the other direction, see if there's any variables in common. There's none there. So that means we're going to go ahead and just multiply the numerators and multiply the denominators. In the numerator, I have 2a times b, so that's just 2ab. In the denominator, remember we're pretending the b is not there anymore. We just have the d. So our answer is 2ab over d. Go ahead and write down number 8, and we'll walk through this one together. All right, so hopefully you expanded your variables. So we have xx over 3y times 9z over 2x. All right, so let's go ahead and start looking for some things that we can reduce here. If I look diagonally, I notice that I have a 3 and a 9. So from those last problems we did on the other screen, remember we can reduce the 3 and the 9? If we divide them both by 3, changes the problem a little bit. We end up with a 1 in the denominator, 3 in the numerator. Anything else that you see that we can reduce as far as the numbers go? I do not see anything else, so now let's move on to the variables. Looking at the variables here, anything in common? No, that's a y and that's a z. Those are different. This way, yep, I have an x and an x. So this x and this one, those are going to cancel each other out. And we do not have anything else in common, so we're going to multiply our numerators. We have an x, a 3, and a z. Remember, your numerical coefficient goes first, so the 3 is always going to go first. Xz over, we have 1y times 2, so that would be 2y. And we're actually just going to leave it just like that. All right, now it's your turn. Go ahead and try number 9. See how it goes. And then you can play the video to check your answer. Play the video along, and then you can have some help along the way. All right, let's see how you did. So we're going to expand our variables. Oh boy, this is a pirate problem. Do you see all the r's in the problem here? We have a 7 over RR and an RSS over 10. So first we're going to look to see if we can reduce anything. And in this problem, when I'm looking diagonal, I see I have a couple of r's. So this r here and this r here, those are going to cancel. Then if I keep looking this direction, I don't see anything. So I'm going to go ahead and just multiply. On the top, there's no r's, just a 7SS. And on the bottom, I do have an r. I have a 10r. Now, okay, sorry to break character here for a minute, but we're just going to reduce this a little bit more. Instead of saying F7SS, we're going to say this is 7S squared. And then on the bottom, in the denominator, we have 10r. I love pirate problems. Okay, have a great day, everybody.